Okay, let's do problem 4. So for part A, we have m to the 4th over m. Now there's a couple ways to think about this. I'm going to show you guys both. So the first one is like this. M to the 4th, we know can be written as m times m times m times m. So 4m's. Divided by m to the 1st, or just 1m. Now this kind of helps us think about it visually, because when we have a fraction like this with variables, we just want to cancel out what we can. So we can take 1m from the top and 1 from the bottom. That's just going to leave us with 3m's up top, or m to the 3rd. Now the other way to think about this is with subtraction. So we can think about it as m to the 4th over m to the 1st. We don't see that 1 because it's just m, just 1m, but we know that that 1 as an exponent is there. And we can do subtraction now. We can say 4 minus 1 gives us 3, which just means that we're going to have m to the 3rd in the end. Okay, let's go to part B. We have k to the 3rd times k to the 4th over k to the 5th. Now that first method where we write everything out is good to visualize it, but once we get bigger numbers like this, we're not going to write it out for every single problem. So we're going to use that subtraction method. I can kind of do it here one more time just to show it. But we're going to want to get to that subtraction method too, because that's going to be a little bit faster as we go. But if we write everything out, we've got k to the 3rd, 3 of them, k to the 4th, 4 of them, and these 5 k's on the bottom. And we can cancel stuff out. So we've got 5 total to cancel out from the bottom. And that means we can cancel out 5 from the top, just leaving us with k squared. Now let's kind of think about that from our subtraction method too. Okay, we know our answer is k squared, but when we get to these bigger numbers, we're not going to do it by writing it out that way every single time. We just want to be able to think through that we can cancel stuff out in that way. So here, let's use our multiplication property first to simplify k to the 3rd times k to the 4th. We know that when we have k to the 3rd times k to the 4th, we add those exponents to get k to the 7th. And we have k to the 5th on the bottom. Now we can use subtraction to say that 7 minus 5 equals 2, or k squared. Okay, same idea for part C. Let's use our multiplication property to realize that p to the 5th times p, this is really p to the 1st, is going to give us p to the 6th. And so we have p to the 6th over p to the 6th. Well, what happens here? Because 6 times 6 equals 0, right? So that means our answer is p to the 0. Although we can write it like that, but really when we have p to the 0, we have to recognize that anything raised to the 0 power is just 1. So we don't know what the value of p is, but it doesn't matter because we raise it to the 0 power, it's just going to be equal to 1. So our final answer is 1. Same idea here in part D. We have x to the 7th over x to the 7th. We're just going to get 1. Because 7 minus 7 equals 0. X to the 0 equals 1.